Thank you. So first of all, please excuse my French-English accent, but I've much more practiced my violin than my English, so excuse me for that. We are Géraldine and Laurent from 3D Various. In the 3D Various project, Géraldine is in charge of all communication and relation with partners, and me, I'm in charge of production, 3D printed violin production, and all the musical parts. And we are very pleased to be in Taipei today. It's the first time for us in Asia, and we are very pleased that it was in Taipei. Thank you.
As Laurent,
Go.
As Laurent decided to create his own electric violin because he had identified some problem on his own electric violin. He set 3 objectives in his creation. The first one was to create a violin with a minimal mass, a very light violin because his first electric violin was a little bit too heavy. The second was to get a violin with a different sound, a sound more warmer, with more bass and less high pitch. And the last one was to offer a maximal playing comfort to the violinist. The project began in 2012 when Laurent conceived on his computer the first prototype. It was imagined in aluminum. The aluminum provides a very light violin, but the design possibilities weren't convincing. So in 2013, a second prototype saw the day. It was entirely handcrafted by an instrument maker in a transparent polycarbonate. This one was really interesting, the design was really interesting, but the violin was too heavy and so very hardly playable. And finally, in 2015, and after a lot of studies, the current prototype, the 3D Various, was 3D printed in south of France. As you can see, the design is really interesting, and the weight is less than 450 grams.
So after choosing the 3D printing technology to create this final prototype, I had to refine my past design, my drawings, in order to catch and to create something lighter with much more transparency and with the idea of freeing the violinist movements. So it took me a long time to consider and reconcile the different parts, the mechanical constraints of a real violin, the design I liked, and the right weight, because this violin is very, very light. It's as light as a classical violin. So I'm an engineer, but I'm not a designer, so I had to find a design I liked, and to find it, I read books, I visited design exhibits and discussed my ideas with people and made a mix of all of that. And then I had my design. I had to integrate the different parts of a classical violin in order to this violin be playable by every classical violinist. So I integrate the bridge, the strings, the tuning pegs, and finally the shoulder that you can adjust to your shoulder. So we choose the SLA 3D printing technology to create this prototype. We choose this 3D printing technology because of its extreme detail precision, the beautiful transparency of its resin, and the strength and the solidity of its material, because the strings create a big pressure on the violin, and the resin must be very, very tough.
Now, we will show you a video about the 3D printing process. So you can see the 3D printing process. At the beginning, we fill the 3D printer with a specific clear resin. Then, you will see the laser being hardens the resin in the shape of the violin. This step takes 24 hours just to print one model. It's very, very long.
So at this stage, all the excess of resin is manually removed from the violin in order to obtain the perfect shape of the violin. Then precision tools are used to completely complete this phase.
In order to protect the violin from external harm, we put it in a UV oven. Then, all surfaces in contact with the strings and the musician body are sanded with extreme precision to ensure sound purity and offer a maximal playing comfort.
Finally, the final assembly. It's the most delicate step because it's the first time when the structure of the violin is subjected to the pressure of the strings. So the stringing and the tuning, as you can see, must be done very symmetrical and progressively in order to obtain the perfect chord.
The Stradivarius has some specific features. As Laurent explained, the Stradivarius is based on a Stradivarius model, but we decided to refine its appearances, and we deleted some classical parts of a classical violin, especially the head. No head to reduce its weight and to optimize its mass. The Stradivarius is 3D printed in one single piece to preserve the sound wave flow. The sound is so powerful that it doesn't need a preamp. And again, to optimize the mass. The bridge and the jack are really closer to limit the signal travel time and limit the radio disruption. The position between the jack cable and the violinist was optimized, not to hinder the musician movements. And finally, as Laurent explained, you can, the Stradivarius can be adapted to any morphology because you can add here any violin shoulder. Even if it's a violin shoulder for classical violin, you can put it on the Stradivarius.
A mirror, something we use every day. Never, it's beautiful.
We are now working on the launching the production. We are working on the final choices of production and the choosing of manufacture method in order to respond to our orders. Then, in a couple of months, we will launch a crowdfunding project to allow people to purchase the first limited edition of the violin, and this first limited edition will have the same design of its first violin and will be called Pauline. In the future, our goal is to go further in the relationship between music and 3D printing.
So, thanks for listening. Now Laurent will play another song with the Stradivarius. Then, if you have any question, we'll try to answer with precision.
Only if we understand the question. Now you want? I had to ask to people. Do you want me to play another song for just 1 minute and a half? Ah, no or yes? Okay. Thank you.